In this video, we'll look at the three types of light. Now, you'll notice some settings are grayed out and inaccessible, but that's because while most settings are common across all three light types, certain settings are unique to a particular light type, and you'll see these as we look at each one. You can see the light as an on-screen icon, by the way, by selecting the light position node, then pressing Shift F11. The menu path for this is View, Show Control. This icon gives us an on-screen indicator of the light position as well as its target, and both of these can be controlled with pegs. In the light shader properties, the directional light type is selected by default. To control its direction, you need to add a target peg to this node, then you can move it around. Note also with this light type how the position of the light doesn't matter, it's only the direction that you're changing. But one quick method of hooking up a directional light is to add a single peg to the light position node like this and plug it into both top ports. Then you can move and rotate the light using this single peg. So in the directional light's properties, the first option we can change is the shading type drop down, and you can either choose smooth or sharp. The differences are pretty obvious when you try them out, with smooth being a more realistic and gradual lighting, while sharp is more of a hard-edged, cartoony effect. The remaining parameters you could use with other light types as well, so we may as well look at those now. The abruptness, intensity, and multiplier values each contribute to those aspects of the light, and you can adjust them while in render mode to see what they do. Surface reflectivity is the strength of the light coming from a surface. It's a value in degrees with a maximum of 90. Next up is the color section. To change the light color, you can enter specific RGBA values, or you can simply click the color swatch to pick your color. Notice that you can also animate these values by creating function curves on each. Checking this Use Image Color checkbox lets you raise or lower the image color intensity value to favor either the light color that you've chosen at 0 or the image colors at 100. And like all fields with this function icon, this value can be animated over time. Spotlight. Just like a stage spotlight, the spot can be positioned and pointed in specific directions for various effects. So with the light type set to spot, some previously grayed out options will become available. And for this example, let's actually cast a light on the background instead of on the character, just so we can see what the values are doing. So for this one, I'm just going to use a single peg for both the position and the target inputs, like I did with the directional light earlier. And before we go ahead, make sure the shading type is set to smooth, which is that more gradual, realistic kind of lighting. The first value we'll look at is the cone angle, which is the cone of light emitted from the spotlight. The higher the value, the wider the cone, and therefore the more coverage. So I'm going to make mine 45. Next up, we have the diffusion, and that's the fuzziness of the light edge. So with the diffusion value of 0, it's a perfectly crisp edge on the pool of light. Also, this is a very sensitive value, so you can get big changes within the 0 to 1 range. So this is 0.3, and this is 0.6, and here's a value of 1. And this one is 5. So I'll settle back on 0.6 for this scene. The next one is the light source elevation, and this is how high your light is above the drawing. So imagine a helicopter spotlight. When it's high up in the air, shining down onto the ground, it covers a broad area. But as the helicopter gradually descends, so it's closer to the ground, the light area shrinks. So changing this value from the default 200 down to about, say, 10, we can kind of see why the light ends up looking the way it does. So I'm going to set my elevation to 120. Now we saw these next few values in the directional light type earlier, but let's change them a bit here to suit a spotlight effect. The abruptness value defines how the brightness of the light falls off. So a minimum value of 0.05 gives a very sharp edge, but I'm sticking with the default 2. The intensity is currently set to 75%. And by the way, just a quick diversion to illustrate the multipliers. I could get the same 75% here by setting the intensity to 7.5% with a multiplier of 10. But anyway, here's an intensity of 100% multiplied by 0.75, and of course that's 75%. This is 1.5, giving a total of 150%. Here's a multiplier of 3, and that's got a nice bright burn at 300%. But for this scene, I'll go with a multiplier of 0.9, so that's 90%. Not too bright, not too dim. And if I just want to switch on the character, we can move the light around and rotate the light peg to see how it looks on him. The point light is omnidirectional, so its position can be animated with a peg, but there's no target control. This particular light type is ideal for lights that emit in all directions, like a campfire or a light in a room or a glowing ball of light floating past a character. The point light has all the same value fields as the spotlight, with the exception of cone angle and diffusion, which don't apply here. So this is an example. Hovering around this character is an otherworldly global thingy. I animated it on a peg trajectory first, then added a particle trail. After giving the character some volumes and normal maps, I attached a point light to the same peg as the global drawing, and this is the result. If you've got a keen eye, you'll notice that there's a bit of volume within the character's face, especially his eyes, and those eye lights are actually reflections of the point light. I didn't animate them traditionally. You'd have to normally animate those frame by frame, but here the eyes reflect the light source automatically. And coming up in the next video, I'll show you how to carve out hollows from a normal map, as well as add extra layers of volume objects and normal maps.